So this lesson is going to be similar to lesson 8, but we're going to be looking at angles as well within the similar triangles. So on exercise 1, it gives us a triangle, ABC, and A prime, B prime, C prime. And it gives us some of the measurements that we would need, but it asks us, is it similar based on the information we have here? So we can see that we have CB and we have C prime, B prime. So we have CB, which is 8, and C prime, B prime, which is 2. So we're going to do the new over the old for our fraction. So we have 2 over 8, which is the same thing as 1/4. So if these are similar, 1/4 could be our scale factor, but we always have to look at other sides or angles as well. So we have AC, but if you look right here, we don't have A prime, C prime, or AC prime. We do have AB prime, which is 2 7/10, but we don't have AB. So we don't have another pair of corresponding sides to determine if this is similar or not. So based on the information given, is triangle ABC similar to triangle AB prime, C prime? We don't have enough information to determine this. And then it says, assume the line containing BC is parallel to the line containing B prime, C prime. With this information, can you say that triangle ABC is similar to AB prime, C prime? If they're saying that BC and B prime, C prime are parallel, that means that they would all have angle A, and that would make them parallel because angle A and angle A after they was enlarged would equal the same thing. So they are similar because we would have the sides that have a ratio of 1/4, and then they share angle A right here, and that would have the same measure in both of them. So therefore it would be similar, and we could write that right down here. So I brought information down. Our scale factor for B prime, C prime, and BC was 1/4, and it gives us AC is equal to 6. So if it wants us to find the length of AC prime, we would take 6, because that was our original measurement, and multiply it by 1/4, our scale factor, and that ends up being 6/4, which is the same thing as 3/2, which is 1 1/2. So that is the side length for AC prime, 1 1/2, because our scale factor was 1/4. For part D, it's saying that the triangles are similar again. It says determine the side length of AB. Our scale factor is still 1/4, so we know that AB times our scale factor will give us AB prime. So that would be 1/4 for our scale factor times AB is equal to 2 7/10. And if we divide by 1/4, divide by 1/4, or we could write 2 7/10 divided by 25/100. That tells us that the side length for AB is 10 8/10 units long. Looking at number 2, it's asking us if triangle ABC and A prime, B prime, C prime are similar. And we do have A prime, B prime, and AB. That would be the same. And if we look at angle ABC right here, that's 92 degrees. And if we look at A prime, B prime, C prime, that is also 92 degrees. So those angles match up. And angle CAB is 59 degrees. And angle C prime, A prime, B prime is also 59 degrees. So because the angles are the same, in the same spot, and they're the same measure, we are able to say that yes, they are similar because the angles measurements did not change. And then it says, given that triangle ABC is similar to A prime, B prime, C prime, determine the length of side AC. So if I erase this, and I know that AC is 6 1/10, A prime, C prime is this side right here that I don't know the measurement of. If I know A prime, B prime over AB is equal to 5 12/100 over 3 2/10. Pause the video now and identify the scale factor for that, and then set up your fraction to find the side length for A prime, C prime, since we already know that AC is 6 1/10. So if I know that my original measurement is 6 1/10, I can take that and multiply it by my scale factor of 1 6/10, and that tells me that my measurement for A prime, C prime is 9 76/100 units.